Hi everyone, my name is Suraj, and today I will analyze the Salmonella outbreak, which was linked to greenfield farms using a One Health lens. So, I will first examine how human, animal, and environmental factors interacted all together to generate this outbreak. And then I will outline an action plan with both immediate control measures and long-term prevention strategies designed to reduce the probability of recurrence. So, outbreak overview. Within 2 weeks, clinicians noticed an unusual cluster of patients presenting with diarrhea, fever, and abdominal pain. 15 individuals required hospitalization with dehydration and stool cultures, which confirmed salmonella infection. Epidemiologic interviews revealed a strong association with consumption of unpasteurized milk from greenfield farms, which prompted a coordinated multi-sector investigation. So, next is evidence from medical, veterinary, and environmental domains. So, from a medical standpoint, the laboratory confirmation of salmonella provided the clinical anchor for outbreak identifications. Veterinarians, meanwhile, detected mastitis in dairy cows, which is a known route of bacterial entry into milk, and necroscopy findings in poultry confirmed animal level infection. Furthermore, environmental sampling revealed salmonella contamination in a stream used for irrigation and for recreational exposure in the community. These three independent lines of evidence all converge to demonstrate a shared ecosystem of transmission, not isolated cases. So it was all shared via these pathways. Speaking of pathways, there are different transmission pathways. For example, they can show cycle rather than a single route. So infected cows entered the milk supply, and then the milk was consumed unpasteurized. And furthermore, poultry provided an additional pathogen reservoir. Untreated manure applied to crops created a secondary contamination surface. And then heavy rainfall then transported pathogens through runoff into a stream that served both agricultural and recreational purposes. So, from this, humans were exposed through food, water, and environment all simultaneously. So, this basically demonstrates why single sector solutions alone would fail. Next slide is the roles of humans, animals, and the environment. So, this outbreak did not originate from one failure point. Humans contributed through consumption of raw milk and through agricultural decisions around untreated manure handling. Animals, they served as biological amplifiers. Mastitis and poultry carriage, they also sustained the pathogen in the production chain. And then the third thing, which is the environment, this acted as a vehicle dispersing contamination beyond the farm through runoff, irrigation use, and shared recreational water. So the event only becomes fully explainable when all three are viewed together. So all three had like an interaction for this salmonella outbreak. Next part is stakeholder engagement. So a One Health response also depends on the correct alignment of stakeholders. Farm owners, for example, implement on-site corrective actions, manure treatment, and compliance with sale restrictions. Veterinarians, their job is to diagnose and manage infected livestock and support biosecurity interventions. Public health authorities, they can conduct surveillance, issue advisories, and coordinate outbreak control. Environmental regulators can oversee water quality standards and runoff management. Schools and retailers, can prevent distribution of unsafe milk beyond households. Local residents can also play a role. They can adopt safe consumption and water use practices to prevent downstream transmission. So basically, a durable solution requires that each sector operates in their role specific uh, and coordinated um, abilities. Next part is immediate mitigation for the active outbreak. Immediate contaminant uh, focuses on interrupting exposure. So first, suspension of all unpasteurized milk sales is necessary, and then after that, isolation and treatment of infected livestock. Um, this reduces ongoing shedding of the bacteria. And then third is irrigation activities using contaminated water streams should be stopped. And then this should be joined with boiling of water and having an advisory for residents to boil their water. And then finally, targeted risk communication. So, not generic public messaging, but having that target message reach all known purchasers of that milk and exposed households. Next part is long-term prevention, specifically regulatory and system level controls. So, to prevent recurrence, the structural drivers must be corrected. Mandatory pasteurization for any dairy product entering public markets is the most straightforward systemic control. And then routine inspection schedules for mixed use farms should be enforced due to their inherent risk profile. Regulation should require pre-treatment of manure before agricultural application and then mandate engineered runoff controls to prevent pathogen transport during heavy rainfalls. So these actions basically convert episodic compliance into structural prevention. Okay, next part is also long-term prevention, but this one's at farm level practice change. So internal farm practice redesign can help as well. This includes regular pathogen surveillance in livestock, antibiotic stewardship, uh, composting or thermal treatment of manure, spatial separation between livestock and crops, and then physical engineering of drainage systems to basically divert runoff away from shared waterways. So these interventions overall remove the conditions that support pathogen persistence in the first place. Next slide is also long-term prevention, community and behavioral lens. So residents must be educated on the risk of unpasteurized milk, and signage should signal that waterways need agricultural near agricultural sites are unsuitable for recreation following rainfall events. And then retail chains should implement supplier verification protocols. When behavior regulation and farm practice are aligned, the environmental and biological chains of transmission stop. So all of these long-term prevention techniques, whether it be community, farm level, or regulatory system level controls, are all important. Why integration matters? If any one of the domain addressed alone is addressed alone, the system remains vulnerable. So treating cows without addressing runoff leaves the environment infectious. Improving water management without stopping raw milk sales leaves ingestion route intact. And then educating consumers without regulating production leaves the risk structurally unchanged. The success of response, therefore, depends not on the strength of any single measure, but on the coherence of the combined intervention across all the three domains, as I mentioned. So, in summary, I think this case uh, demonstrated the value of the One Health framework. Medical data described the illness, veterinary data explained the reservoir, and then environment really revealed the transmission vehicle. So only when these were integrated together, the outbreak can become solvable in a way that translates to prevention. And then the challenge of One Health work is the need for coordination across different sectors and rarely collaborate. So the benefit is that resulting control strategy is not temporary, it's durable because it matches the true complexity of the problem. And that was my presentation. Thank you so much for listening.